going to make a very simple thing in a complicated way to show off how to use a method. So this is mostly for laser cutting. Could potentially be used for other things, but mainly it's for laser cutting. And what we're going to make today is basically just a dice or a die, one of a pair of dice, like if you're playing in a Vegas casino or something like that. And it's going to be laser cut, so it has 6 sides. And it's basically the simplest box. I mean, it's all 90-degree corners. It doesn't have to open up. We can put some designs on the sides, but it's a very simple thing. What makes it complicated is this is going to be parametric. So I already went ahead, made a new part, and just as a note, I have all of this customized for my needs. When I pick a command, I will try to read it out to you so that if you can't find it in this bar, you can just click right here, select commands, and just start typing it in, and it'll come up. So, for instance, insert part. So there you could do insert part that way as well. Okay, so I want to go up here to File Properties, and we can select Configuration Specific, and we want to start adding some data here. So the first thing is this is going to be made out of wood, and the tricky thing of making something out of wood that's relatively precision is that wood is not the most precision material. You buy it and it might say it's 5 millimeters thick, and it turns out it's 4.5, and the next sheet from the same stack is 4.4, and so on. So if you're making a design for wood, you want to be able to type in the actual thickness of the piece you're using to make that part, and just regenerate it, as opposed to redesigning it every time you've got a new piece of wood. And if you're making 50 of something, you don't want to redesign it 50 times. You'd rather just type in that number 50 times, regenerate it. So I'm going to make something called material thick. That way, if I decide to make it acrylic, that's still a logical name for it. And I'm going to call this 4.5. That's pretty close to the wood that I have on hand. I haven't measured it, but or the particular piece that I'm going to use I haven't measured, but that's about the average of what this stuff is. I'm also going to make a line called Kerf, which Kerf is basically it's what you lose when you laser cut. So you're cutting some material away between two pieces, and it's basically the width of the laser beam as it cuts through the material. And I happen to already know through experimentation that on my machine with this material, I get a kerf of 0.11 millimeters. Now, we're making a dice, so we don't have a whole lot of things as far as shape to worry about for dimensions, but I do want to just make a dimension called dice wide. And say 50 millimeters. That's about 2 inches in U.S. standard. And we can come back to this later, but that's a good start. Okay. I'm going to start on Z. These are renamed and changed. I've got a custom template, but you can start on whatever you want, really. And I'm going to do a center rectangle and make these two equal. And I'm going to dimension there. And instead of typing in that I want it to be 50 or 100 or whatever wide, I'm just going to type equals. And I can go down here to File Properties and dice wide. Okay. And I'm going to go ahead. Oh, yeah. I'm going to select this chain. I'm going to offset it the other way. I would type in equals here, but it won't let me. But I can type it in here for some reason. So I'm going to go equals material thick. So basically if we cut off the top and bottom of this die, just looking straight down, this is basically what it would look like. So I am going to extrude this, mid-plane extrude, and this is going to be equal to dice wide also. Okay. And I'm going to just put caps on the end. Equals too thick. And on this end as well. Actually, I can reuse this sketch. Okay, so I've got a, oh, sorry, I want to merge that, yes. Okay, so I've got a box here, it's an empty box. It definitely can't laser cut this right now because it's just one piece. So we need to divide it up basically. And how I'm going to do that is I'm going to start a sketch. And just for my own memory later on, in case I want to change something, I'm just going to make this circle here. And I'm going to rename that as memory anchor. That way I know that if I'm dealing with something that's on this edge, it starts from there. If it's on this edge, it starts from there. If it's on this edge, it starts from there. And it also, for instance, if it's on this edge, I know that it's a mirror of what's on this edge and that it's starting from there. Or so then it would be starting from there. Okay, so we want to basically make some fingers that will allow this to go together because we want to make this in 6 separate pieces and then just put them all together. So first thing I'm going to do is make all those equal. And just trial and error that this, with these corners, I figured this out, is that generally it works really well if we just go material thick times 2. And then we can go between these. So basically we could go rectangle or square, 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 and with this size we could figure out that maybe that's 3 or 4 of these squares would be the perfect size. But what if we then later on decide, hey, we want this to be 100 millimeters, 200 millimeters, 400 millimeters? Then that doesn't really work anymore. So what we have to do is use a little bit of math and basically force SolidWorks to decide how many. So I'm just going to make this a horizontal line. And actually I'm going to make a few of these. And these I'm not actually going to use for anything except that they are going to be used for math. So they aren't going to be actually made into features. They're just going to be used for math. So I don't feel guilty about using a number here because, again, not going to be used for anything but math. And again, just drag some more lines off there. And one parallel and perpendicular. Okay, so for starters, let's say this equals dice wide, obviously. We'll start with there. Then we want to subtract, say, this and this. So that would be 2 times this, which is itself 2 times. So it's 4 times our material thickness. So if we leave it right like this right now, we get 32 exactly. And if we measure like this too, we see that matches up as well, 32. Okay, so our second one is going to be, we want this divided by our material thickness. Okay, so that's telling me that I could have 7 fingers. That's a total of 7. So if we were cutting out the top plane here, then that would either be 4 or 3. And since I've already decided these are going to be staying, this part that are the rectangles right now, those are staying. So the cut would be right next to them. So that means we would want 4. So first thing we want to do with this number is, since it's a number of cuts, we can't have it be going to a decimal point. And SolidWorks gives us 2 ways of doing that. First, we can do something called, I don't even know if it's in here. Yeah, probably not. We can do something called round. And if we're careful, we can grab that, and that'll round it. So if this is under 7.5, it rounds it down to 7. If it's over 7.5, it rounds it up to 8. However, in this particular situation, if this was ever rounding up, that could cause us issues. So what I want is to use something else. And that is int, which is just like round, except it always rounds down. In case you're wondering, there is nothing that always rounds up. There's also nothing that always rounds to an even or an odd. You've got round and you've got int, and then you can play with those a little bit with some other tricks to get to other things. So we've got int, and that would be great by itself. But in very specific circumstances, it can cause us issues later down the line because we're not quite done with dealing with this number. So I'm actually going to cancel that. So I want to get this out of the way. I want to take that, and I want to divide it by 2. Actually, I want to subtract 1 from it, because I want to make sure I'm getting an odd number, and divide it by 2. Okay, so I want to get an odd number eventually. This happened to be an odd number right now, but even if this came out to be 4 point something, it would still work for what I need to do. So for this one, I'm just going to do int, and this can get in your way pretty easily. Okay, so right now I have this, and this is going to be very useful for me. So I'm going to use this a few times, and because of that, I want to give it a name. And let's call it num cuts lower. So if we ever need 4 to match the 3, we can just do a +1 on it later. Okay, and I'm also going to go ahead and change this just so I can find it later. Call it skeleton1 for skeleton1. So now it's num cuts lower at skele1. All right, and we actually don't need this. Okay. And let's make a new sketch. This time, let's start from right there. And this direction is just going to be our material thickness, because it's going to match up with this piece right here. And then we want to pattern this. So we're going to take a linear pattern, and we're going to go We won't need 101, but I always like to type in 101 because it kind of forces it into a higher mode. And then I'm going to do 2 in the other direction, which is going to be the one down here. So I can constrain that down here. I can constrain that right there. And then I can change this. I'll just copy this so I can use it later. So now that figures out the number of cuts. But we want, again, we're trying to make 4 cuts up here. This just gives us the 3. So I'm going to do +1. Okay. And it's a good time to go with Notepad. Just start writing down handy things because we need to actually go back here because we need this one too. So I'm going to call this top, bottom, finger space. Oh. Yeah, it doesn't like minuses in there. So we basically just copy this part and copy this part, and there we go. So let's go back to here, and we want to drive this. We already have this driven. So we want to know, we want to tell it how big this is going to be. And how we can do that is where the notepad can come in handy, as well as we can design out our equation and type it in because we only have so much space right here. So we want this total distance from here to here, and we want to divide it by the 4 plus the 3 in between. But again, if we change the size of this box, we want it to adjust for that. So we're going to divide by the number of cuts plus the number of cuts again plus 1. So this is kind of a long equation, but we can just copy and paste into that. And since we're going to be equaling between the two, we just put a line there for construction and equal. And then we've got that right line on line. And we're going to do basically the same thing here. And since this is symmetrical in all directions, we can kind of cheat. We don't have to redo all this again. We can just do some equals relations. But if you were doing something that's a little bit more complex, rectangular, or whatever, you'd have to kind of go through all the equation design again. So chain, and we want to go 2 that way and 101 this way. Switched around. And go coincident. Sometimes it momentarily freaks out because all of a sudden we made 202 entities with 4 things each. So that's a lot of lines for it to keep track of all of a sudden. We want to try to just grab it, drag it out here so we can double click it. And I'm going to go equal to that. And again, we're going to do just a line in between here for construction, and we're going to go equal again. And just do some coincident there. Okay, so that's going to be all the cuts that I'm taking out of the top and out of the bottom. But if I cut that right now, it's going to be, I'll cut it right now anyway. Just go through all. Okay, so that's cutting all the bits off. And I'm going to go ahead and just wipe out everything in between. We can add it back in later. And this will just kind of cheat, make a circle that's really big. Bigger than anything I'll ever laser cut, at least on this machine. And it'll ask me if I want to keep bodies. Yep, I do. So now we've got top and our bottom. And just for the sake of keeping myself sane later, I'm going to give these names, which are real easy on this one because it's just sides, but on some more complicated boxes, it's tricky to figure out what name you want. Okay, so we've got our fingers designed here. And it's pretty easy to design the fingers for that match with them using another tool. But we still have to design these fingers here. So let's start a sketch on this plane. And let's make a rectangle. And we're just going to go up to surface. We don't want to merge this one. This is just going to be what we add or what we subtract from. Oh, but that was actually a mistake. I am going to redo that because I did that wrong. I want to go from corner to corner. Yep, so that I can do another command later. Okay, and I might as well show what that command is right now because I can do that. So first I'm going to do a move copy bodies with, in the translate rotate mode. So I just want to select this and this. I want to be in copy mode. I just want one copy and OK. I'm going to hide these real quick. And then I'm going to do a combine and select subtract. So I just want to start with this one and subtract and there. And the reason I do it like that is even if I change all sorts of stuff around, it's going to remember that I just want to take the existing bodies, subtract and subtract. So if there's 100 fingers, it'll just make 100 fingers when it does it. And these, of course, are still there. We just hit them for a second. Okay, so we've got fingers on the top, fingers on the bottom. We don't have them on the sides. So we want to do a sketch here. And just draw a rectangle. And again, we're going to go with material thickness. Nice and easy there. And just get it kind of sort of close. And then we have to decide, do we want to start cutting or do we want to start with a cut or do we want to start with a solid bit? And just from my looking at it, I think I'd prefer to start with some solid material than a cut and so on and so forth. So it's solid on both ends. So again, we need to do a little bit of math in here. So how big is this line? Well, we could measure it pretty easily, but that can change later on. So I'm going to do this thing with the math bars again. And just set these up real quick. It doesn't matter what you make that dimension. And draw more lines. Maybe I won't use all these, but it doesn't really matter. Okay, so how do we get this? We get the original 150, whatever we've got, and subtract the top and the bottom. So that would be equal to our darts wide minus our material thickness minus the material thickness again. Okay, and let's divide that by the material thickness. Okay, so roughly 9 fingers can fit in here. Let's Let's divide that up. Equals that. Oh, we want to go use these parentheses to separate it out. That minus 1 divided by 2. Okay. And then we want to use the int thing on it again. And this is going to be, what did we call it last time? So num cuts side. Get that out of the way. Okay. And we also ended up needing to go back to get this. So that was this. All right. And again, we don't really need this, but it's not going to hurt anything being there. And I'm going to call this scale 2. And speaking of which, I can go ahead and hide this. Don't need it right now. And let's see. Let's just go ahead and make these lines so that we can use them a little bit easier. Make a new sketch. And I'm going to hide scale 2 as well. So I wanted this to be solid, cut, etc. And I'm going to do equals material thick again. And this time we want to pattern these. Actually, it might be easier if we go the other way, if we pattern it after we've located it fully. So we want to divide this by that. So we'll set it up here first. So our total space divided by the number of cuts. But it's not just the number of cuts, we want the number of cuts plus itself plus 1. I believe, if I set that up correctly, it should come out just about right. Okay. And just to anchor it, we'll put this here, go parallel, equal, and for construction. All right, so now we need to select this chain, and we're going to make a linear pattern out of it. Direction, and direction again, and 101, and okay. Okay, so now we want to set this number here. And what do we want that number to be? Well, we want it to be the lower side, so it should be just equal to this time. Looks about right. Oh, I did not mean to go midpoint. And you can see these are blue, so we just need to do a coincident there. That'll turn that black. So we've got black, black. The only blue is here. And we can adjust that by just making another line right here. It's also for construction, and it's equal to that. And clearly I need one more. So plus 1. Okay, so that did not come out correctly. Oh, did I? Okay, let's go back. So where did this go wrong? So you get the totals divided by the material thickness. Okay, that's fine. Then we subtract 1 and divide by 2. So that should get us the lower. So that would be 4 plus 4 plus 1 would be 9. Okay. Perhaps I entered it here wrong somewhere. So it's total divided by numcuts plus 1. So this should be 4 plus 4 plus 1 is 9. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's odd. What happens if we just change this to the later part of the equation? Does it give us 10? It gives us 9. So it is dividing this total space by 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And what is this? This is 45.5. We go back. And this, why is that wrong? So we made this 50. That's 54.5. So it's so this is one of those things can go wrong very early and you don't even realize it. So that's the beauty of this bar right here. So right here, 50. Great. Right there, 50. Okay. Right there is our problem. So we want to go the other way. Okay. And we get all the way back down here. And we have errors, of course. And so it's going to complain that that doesn't exist anymore because it doesn't. Yeah. Just cut. We need to also adjust that. And we want to go up to this surface here. Okay. Yep. So this, we want to fully define again. So we can go to there. Yep. Continue the legal error, blah, blah, blah. And we want to move copy bodies, which it's kind of freaking out because that body it had didn't stopped existing for a second. So this is bottom. And combine. So this is going to be the side, but we can rename that later. Okay. And with all that sorted out, I didn't need the one after all. And so this is 4.556, and this is 4.556. Beautiful. That's what we want. So I guess I'll probably leave that in because that just, yeah, sometimes you got to go back and figure out why something isn't working. You know, just click the wrong thing somewhere and didn't even notice it. Okay, so I've got a side. And call that side 1. Side 1. Okay. And since I know this is perfectly centered around the origin, I can go ahead and mirror that side over to there. Call it side 2. And then I just need the front and back. And how I can do that is draw a rectangle here. And I'm going to up to surface to there. Now I want to make sure it's one of them that's always going to be working. If I did this one and I made it smaller, that might not exist anymore and then it would throw errors later. And come to think of it, I may have already made that same mistake here. Did I? No, I did not. I could. Sometimes I do make that mistake, and I know I shouldn't, but I do it all the time. So again, I want to do a combine, but first I need something to combine. So just make copies of these and then hide them. And then we'll just cut away using the copies. And show them all again. And then here we also want to mirror that. Okay, so now we have a box that's all lined up. And this is a relatively simple one, but just to be sure, I always like to go to evaluate and interference detection and just calculate. And if I mess something up, it would tell me, this is overlapping with that, it ain't gonna work. So that looks good. We've got a basic box design, but we're not even close to being done yet. For one thing, actually we have three main things. First, it's assembled as a box right here, and we are going to want to lay it out all flat so that we can cut it from a single flat piece all in one go instead of doing it 6 separate jobs. The second thing is that this value here, the kerf, when we're cutting, we're going to be cutting material away. So if we cut line on line, it's going to be a little bit too small. Each of these teeth or fingers are going to be a little bit too small, which means it won't fit very well. It'll fit very easily, but it'll be kind of sloppy. Maybe you like that just because the box is easier to assemble that way. You're going to glue it anyway, whatever. But maybe it's a more complex design. You don't even want to use glue. You want it to be all press fit. That's where the kerf really comes in handy. So we're going to adjust the kerf. The last thing is that with these fingers, a lot of times these hard edges are hard to assemble or difficult to assemble. And just putting a little bit of a chamfer, like this tool here, on each of these edges, so there and there, and all the way down, it really helps with assembly. However, this tool is useless for that for our purposes because we've got a whole bunch of them, and we might have more, we might have less. It's going to throw an error. It's not going to do as many as we need. Whatever. It's just not going to be a good thing for us. So we need to deal with all those things. First thing I think I'm going to do is the chamfer. So I'm going to hide everything except for the top. We'll start on that one. And again, got this here. That comes in handy. Just reminds me I want to start from up over here. And I'm just going to manually draw the chamfer for one of these teeth openings, and the same for over here. And I'm going to select all the straighter, all these edges that are up and down, because I want them to all be equal. What do I want them to equal to? Well, let's make a new variable for that. Call it a sem chamfer. And it doesn't have to be huge. Just a little bit goes a long way. So I'm going to do 0.2 or 0.20. So 0.2 of a millimeter. Not much, but it makes a serious difference when you're assembling it. Okay, then we need to go back to our equations here. And num cuts. So we want to, actually, before we do a linear pattern, we want to mirror these. Which I should have started from here. Sometimes I just start from something that might not exist later. So start from there, start from there. I'm going to make these perpendicular and equal, and then make this one perpendicular And these are just going to be reference lines. They don't actually get modeled as anything. So we want to just have them there. We select this, and we want to mirror it across that. And then we select these, which we want to mirror across that. And then we can grab one of the points and make it a coincident. So that's fully black, fully defined. And do the same thing here. Coincident, fully defined, good deal. And yeah, just to get rid of the last little blues. There we go. And then we need to do our linear pattern. So we want that, and we want such. I'm holding control right now, by the way, so that it keeps selecting as I go. And I want to do a linear pattern, going that way. Call it 101 for now. I'm going to fix that because we want to be that, which maybe wasn't the perfect name for that variable, but whatever. Okay. Probably going to have to go +1 on that. Yeah. We'll go ahead and anchor this one first. +1. Okay. So that'll cut there and over there. So we need to do the same thing here. And I'm holding control and then selecting everything that I need, that I want to do. I can select these later, but it's just the way I do it. I think it goes a little bit faster if we do it this way. So I'm going to set that to 1 because I don't want it to go that way. I want it to go this way, not that way. And again, 101. And down. And drag this out of the way so that I can double click it without hitting something else. Make it equal to that. And then we lock that down. We are fully defined. We're going to cut this out of the top, but the bottom is the same, so we might as well do both of them at once. And we just want to select our bodies. Okay, so it almost looks the same, but if you look closely, just a little bit of a chamfer there. Just makes it a little bit easier to put it together. Not a huge change, but it's a big change when you're putting it together. You really notice the difference. And we have to do the same thing here. This time we're cutting from the actual teeth instead of from the opening, which, depending on how you look at it, is basically the same thing. But we just want to do exactly the same thing we did before, so we'll do it again. And just want to select all the non-angled parts of these chamfer cuts, make them all equal. Then we want to make them all equal to that variable. And there we go. And again, this line I know is solid. It's going to be there all the time. This line is also going to be solid, always there. For construction, perpendicular and equal. And then perpendicular as well. I want to mirror these across this line. And we want to mirror these across this line. And we'll constrain them again. constant. And again, just to get rid of the last little bit of blue there. All right. And we're going to have to do another pattern. This time we can just drag around. And we want to linear pattern going in this way. So 101. It's going the wrong way. There we go. So we're going to use that again. We can try to grab this dimension. Sometimes it's a little bit slow. Yep, sure, it's running a command. What command? No command. This happens too much. Okay. Get this out there. And probably have to add one to that. Yeah. Okay. And let's do a coincident there. So those are also lined up. Let's do the same thing with these. And linear. I'll go the other way. 101. And we lock this down. So that's fully defined, fully defined. This one we want to be uncut side. Maybe we want to be +1, we'll see. Yeah, we don't want to be +1. Okay, this is fully defined. Let's do cut through all for both of these. And yeah, this is a little bit time consuming, but saves a lot of steps later on if you want to change things around. Okay, so this is the last one that we need to do still. So let's hide these. Oh, I forgot to name these, so front, back. Okay, again, that's there, so we're going to want to start from up here. I want to be careful not to hit that, the midpoint. We don't want to lock to that. And so we select those, select these, and size them. Again, we want to make 2 lines to mirror about. For construction, perpendicular and equal. Perpendicular there. So we want to mirror these across that. And we want to mirror these across this. We'll constrain them at the bottom as well. And at the side. And again, we'll just do a coincident there so it's fully defined. And then we can do our linear pattern. So I really like this this way of selecting as opposed to the box tool because I can do stuff like that. Oh, I don't want a mirror. I want to do a linear pattern. I just said that. Okay. 101 again. This time we want it to be that +1. Okay. And just do a coincident here to lock those down. So we're fully defined right now, and we just need to do these two. Linear pattern again. See which directions go. 101, okay. I don't know if I mentioned it before, but the reason I'm always doing these as 101 and then adjusting them downwards is that if you do them too low and try to adjust them up, sometimes it'll throw an error. But if you do them really high and adjust them down, it doesn't. I think it's the kind of variable it uses to store things behind the scenes. I'm not 100% sure what's up with that, but I just know that if I start them at 101, they work going down. If I start them at 2 or 3, they don't always work going up. Not entirely sure what the magic number is where they start working going up, but 101 has always worked for me, so I just keep using it. And I believe this was +1. If it's not, we can always remove the +1. Okay, so I don't need the +1 on that. Beautiful. That's fully defined. We can do our extruded cut. Again, through all, select both these pieces. All right, so all 6 of our sides now have little chamfered edges, which once this is assembled in real life, it's very hard to even notice that those are there. But during the assembly, you do notice the difference because it's just so much easier to push them together versus having 2 hard, sharp edges right against each other. Being able to just push like that, especially if you're pushing these in at an angle with each other, huge difference. Okay, so that's problem 3 of the 3 problems I had with the design before. Problem 2 is that I need to address the kerf. So here's the thing. My laser cutter actually has kerf offset functionality, so I can tell it the kerf and it adjusts to that, and it usually messes it up and it ruins a piece of wood. My previous laser cutter didn't even have that kerf function there. The software that came with it originally had the kerf function, and apparently it worked so badly that they just disabled it rather than fixing it. SolidWorks, the people that make SolidWorks will tell you you don't need a kerf, you don't need to worry about kerf. Just send it to manufacturing, and they'll figure that, and their machine will figure it out for you because they all have this. Well, they don't all have kerf offset, and the ones that do don't always work so well. So I like to do kerf from within SolidWorks. Just send it to the machine and say, follow this line, don't worry about kerf, and it does it right. So that being said, there are a couple ways we can do kerf. I'm going to show you the simpler one real quick, and then actually I'm just going to mainly show you the simpler one. The more difficult one is basically you draw in the material that would be cut away by the laser. Rectangle here, rectangle here, rectangle here, rectangle here, mirror it. Basically just the same as what we just did with these. And I don't want to be repetitive. Well, I suppose I already am, but I don't want to be extra double super repetitive by doing that. So for this one, I'm going to show you the other way. It has a couple issues. First of all, it only works on outside edges. So if we had holes, say if we had an overhang here and that these slid into, and we had the holes, this would not work. You'd have to use the method that I showed you basically for everything so far. The second is that it's really slow, which for a box this size, whatever. It's not a big deal. For a really complex part, it could take like hours to regenerate this. So with that said, I'm going to basically click offset, and I'm going to put it nice and low. Just click the face itself. I don't want the edge. I just want the face itself. and OK. And just in case if I had something in here like a circle or square, cutout, whatever, that I didn't want to damage, I could click Convert Entities, and then basically now I've got this little tiny sketch that basically all it's going to extrude is this little tiny area. And what I want for this is Kerf divided by 2, because remember, Kerf is the total total material loss. So we only want to offset half of that. And I'm going to extrude this up to there. And I only want to merge it with that top piece. And then I'm going to reuse that sketch. Actually, I'm going to take everything up to here. Just put it in a folder called model. Then I'm going to reuse the sketch. Start from this surface here. Come on. Oh. This surface here. Up to this surface here. And that works. Okay. So top and bottom are dealt with. We can hide those. And let's do, well, doesn't really matter. I'll do offset, blah, blah, blah. Again, I don't have anything in here, but so I could actually just extrude just this way. If you've got nothing on a side, it's completely like this. You don't need to do the convert as well. But just in case later on I decide, hey, I want to add this other feature and I add it to the model feature before the Kerf, I wouldn't want the Kerf then to delete it without me really noticing it. So again, we've got just a little tiny space between the lines. That's all it's going to make. Actually, if we zoom in, that's what it's extruding. And because I was just talking, I just want to double check. Yes, that is what I sometimes I forget to change the dimension from the default because for some reason while I can drive that parametrically, I can't type it in the parametric equation onto the bar over here. I have to just type in a low number and then change it later. And sometimes I forget to change it later because of that. And just one more. Again, by converting the face and offsetting the face itself, it will adjust. So if I add more fingers or subtract fingers, it's not going to throw me an error because of that. Because it's not so much offsetting the fingers, even though it is, but what it actually thinks it's doing is offsetting the face itself. And this is going relatively quickly because it's a simple, not very complex design. If we had, say, 100 fingers across and 100 fingers tall, and doing this would it wouldn't crash the program necessarily, but it would take like an hour for each one of these, and it'd be easier to just do it with patterns. It would take less time to do it with patterns. This, with only a few of them, it takes less time to do it this way. So you got to adjust your style to what you're making sometimes. Okay, so we've got everything modeled up the way we wanted it, and we've got the Kerf. So one last problem. We want these all laid out nice and flat. And how do we do that? Well, we want, first of all, I'm going to go ahead. Actually, I'm going to leave that for now. So what I'm going to do is this move/copy bodies thing. It's a very useful feature that is sometimes horribly broken. So, for instance, if I Obviously, if I move and I constrain you to this thing, and then I redesign it so that that doesn't exist, it's going to throw an error. I'd expect that. What I would not expect is that if I went back before this laying it flat thing and added, say, a little design right here, uh, that it would freak out and just fail to do it entirely. And sometimes not even tell me that it failed to do it. And I could look and see, but if it was a little piece, maybe I wouldn't notice. It's kind of a mess. Uh, so, before I do that, I want to make sure that everything is entirely done. And what else could I want on a dice? What feature do dice have? They have numbers on them, right? Or they have dots or sometimes symbols, but they aren't just all blank on all sides, right? So, um, first of all, what the singular of die was, or singular of dice was, which is die. So I went ahead and saved this. And then I grabbed one die from my collection so that I can go ahead and draw these dots on correctly in the right orientation. Went ahead and rolled back before we did the kerf. I can roll that forward again and still have the kerf, but I want to work without it. So this is just a little bit of real basic geometry. It's not even necessarily related to doing laser stuff, but whatever. It'll be relatively quick. So we want to do I'm going to do this as a circular pattern. Just a little bit unconventional for a die, but it's my die and I can do what I want. And do that there. Concentric. And I'm going to do this just as construction. Tangent, and want, say, whatever size this is, the offset might change. So I actually don't want to use offset, I guess. What I want to use just a circle, and I'll try to make this all geometrically set between them. And there. So make these all, come on, give me collinear. Okay. And for construction, collinear equal. And again, I'm going to go ahead and hide the sides so that I'm grabbing what I want to grab. And make that tangent. So that is that. Then we want one more between there and there. Again, for construction, collinear equal. And there we go. So that's 6. I'm just going to do a 0.01, just a tiny little nothing of a cut, just enough to get the lines. But if you look at it, there's almost no cut there at all. So let's bring these back. So the side over here is going to be 2, then a 4 at the front. Let's do the front, I guess. And again, going to go tangent, and I want to go concentric on that. So that'll be fully defined. And then, let's see, we want this to be the same size as those. So what I'm going to do is I'm just going to convert that. So I've got a line. Draw a line across, coincident, and make these parallel, equal, and for construction. And we want a circular pattern again, or at least I do in this case. And concentric. This we do not actually want to cut. We want this to be coincident, like that. So then we want, basically, let's see, I'm not actually going to cut this one, but we want it there just for construction purposes. So there and to there. And we want this to be collinear. We want these both to be collinear for construction and equal. And we'll do that same tiny little nothing cut again. So what's on the back? The back is 3. And we can actually take some elements from the front. Let's say, take those just to make things easier. And one, we can do a circular pattern to get the other 2. That's not what I want, but that is. Let's hide these, or make them for construction, that is. That actually automatically did itself, so I don't have to do that. Alright, so then I need to go there and there. Go make that collinear as well. And we make these collinear equal for construction. Oh, that actually did not make itself coincident, but there we go. It's concentric. So extrude cut again. So it's the side opposite 6. That is 1. That's nice and easy because we can just convert the center. And extrude cut. And I only want to be on that body. And not that it would be on any other body anyway, but I like to do that just as good practice so that I don't forget, basically. All right, so if that's 6 and that's 4, then this will be 2. I'm going to convert this again so that I've got the size I need. And just need 2 of these, so I'm not going to bother with a pattern for 2. Make these parallel, equal, and for construction, and coincident, and make these equal as well. And this is the corner I want to work from, so make that tangent. And let's make makes all these. It's horizontal in this view, but it's vertical from the way we're drawing it. It doesn't really matter. Put this in there. We're just going to use that for construction purposes, but we're going to make it equal. And then we can go from there to there, there to there, and there to there. These are all going to be for construction as well. So they're all parallel, equal, for construction, and then I just do one coincident there. That's fully defined. Don't need this either. So extrude cut again. So we've got all those. What's opposite 2? 5. All right. So we can use the sketch here just to save a little bit of bother. And we can also use this sketch to save a little bit of bother. So we can go equal. So at least we don't have to dimension that. And then we want a pattern of 5. Okay. and we want it, oh, first make it correctly oriented, and we want it to be coincident with the origin, because everything here is centered. Otherwise, we might want to draw in some geometry to figure out where it's supposed to be. Let's convert that, and then we can just make a line there. Make these perpendicular, equal, and for construction, and then we can just use this for a tangent reference. And there we go. So, okay, so all sides are now labeled, and we can just go ahead and I'm going to make a new folder for these. Yep, called number dots. Good enough. Okay, so all the issues are now sorted except for laying it out flat. I'm going to roll forward the kerf, and then we want to just lay it out flat so it's nice and easy. The reason you want to do the dots first, because sometimes it's really weird when this move copy body feature is screwy. Sometimes when you do a subtract or a cut or a cavity, it doesn't affect this. Sometimes it does. It doesn't seem to matter if it. Obviously, it freaks out if you remove something that you constrain to, but sometimes what you change has nothing to do with what you constrain to, and it still freaks out. It could definitely use some improvement, but it's kind of the best we've got right now. And ideally on something like this, something really simple, we would use the rotate version of this and just rotate and move and all that. But since you might be doing something a lot more complex, that might not be available. So we'll do it this way. So I select the side I want to change, and again, up here is the starts. This face is always going to be there. This face is always going to be there. And I'm going to put just 2 millimeters between them. That's just trial and error on my own machine. Any closer than that, I tend to burn the wood a little bit too much. So, and in this case, see, I'm trying to have this match up with this. It's matching it the wrong way, so I can just go like that. And again, this face is always going to be there. This face is always going to be there. Okay, so that's one flat. And then we repeat, basically. Always there, always there. And we want 2 spacing. And again, it flipped it over the way we don't want it, but we can flip it around. And there. Actually, the way I drew it, this is always going to be there too, but it's just as easy to use that. And the bottom one, a little bit trickier, but not too bad. So we actually want to go from this side to there, flip it, and then go to. So this is off somewhere. Sometimes it bounces off way off into space and it's hard to find, but it seems to be okay this time. And this matches up with that. Okay. And sorry, just 2 more. So this is always going to be there, and this is always going to be there. Sometimes you just start with, I know these will work, and work from there. And so this will always be there, and this will always be there. And then there, and one more. So this one's always there. This one's always there. And let's see. Go ahead and do the faces. Okay. And this can get confusing sometimes, so we're going to roll back before it. And so this is always going to be there. It's just to make things easier on myself, I'm going to put a little mark there. Just extrude cut. Sometimes when you're flipping things around, you get confused so easy. So just putting a little mark there, roll that forward, modify this one so it's there to there. Okay. And with a little bit of luck, when I delete this, it won't freak out. Okay, it's fine with that. And so that's our die laid out. And we hide that. And we normal too. Okay, so that's our die fully designed. It has a kerf, it has numbers. We'll go ahead and just make a new folder here for flat. It's all good. Let's save it as it is. And then we can do a file, save as. And what we want is, depending on your laser cutter, this will vary. Most laser cutters want DXF. You can also save as DWG if you want to send it to another program like AutoCAD, but those will usually use DXF as well anyway, so I'm going to save it as a DXF and save. And I should have mentioned, before I save it as DXF, I click a face and then I want normal too. And save it. Takes a second to go. Okay, so that's what we're going to get in our DXF. We click save, and then we can load it up in our laser cutter software. I'm going to be a piece of scrap left over from something else I cut, and measured its thickness. Measured at all four corners, and it's kind of long, so I measured about equally between two of the corners on each side to get maximum thickness of 4.48 millimeters. So I'm going to change this to 4.48, and there's just barely enough to do 50 millimeter, but I'm going to leave myself a little bit of wiggle room. Again, I'm making this out of scrap. If I wanted to make something really nice, I'd probably go ahead and, just get a proper sized piece of wood. Okay, and I'm going to do a Control Q. And we get an error. What error did it give us? Gave us an error with that. That's interesting. Okay, what did I mess up? Everything, it looks like. It's tangent and coincident. So equal, equal, equal. Ah, I see. So if I make that equal that, maybe I see. Okay, that fixed it. Just a little bit of unnecessary equalness. Okay, so that's fixed. So we did a Control Q. I'm going to do a Control Q again just to be sure. And we're good. Do a file save again, and then a file save as DXF. And we'll save. Now, the next step would be setting this up in the actual laser cutter software. And since there's so many different laser cutter softwares, so many different laser cutters, I'm not going to waste your time with that. But basically, we'd want to import this file, make sure that it imports in the right dimensions, obviously, because DXF is a dimensionless format. And then we'd want to select all these circles and change them to a different color or a different cutting layer, depending on what your software uses, so that it's cutting these, but it's just engraving these, or it might even just be doing a really fast cut around the outside just so you've got a basic circle. So I am going to go ahead and cut this out, or I'm going to set this up, cut it out, and